Okay, guys, I told you we would finish up the notes. Make sure you have your composition book out and write down what we go over. The best you can, the best you can fit it. This is what your notes kind of look like. I know my definition might be a little different than the one you have on your paper now. At the top, I want you to add the topic is linear versus nonlinear. And I want you all to write an essential question for today. I will be looking for this during your binder test on Wednesday. Okay? So, this was one of the first ones we had in there. The way you find out if something's linear is, yes, the way we were looking at it, but what if there's numbers skipped in the pattern? Now, on this one, there wasn't, but on some of the ones that we get to, there was some numbers skipped. So, we're going to treat this like we would if there was or if there wasn't. Okay? Now, on here, remember we talked about slope is change in y or delta y over change in x. You guys know the formula, y2 minus y1, x2 minus x1. Okay? If I had a highlighter, my y2 would be purple. This one, because it's the second one, then my x2 is purple because it's the second one. Some of you get confused or put X on the bottom or whatever. Make sure you're looking at that. Oop, that's ugly. You can't read that one, or you can't really tell. So here, that's Y1. That goes on the top. That's X1. Okay, so now what we're going to do is we're going to check change in Y, change in X on each one. So first, 10 minus 7 is 3. And then 15 minus 13 is 2. Okay, so then I'm going to check the next one. 13 minus 10 is 3. 17 minus 15 is 2. So far, so good. Next, 16 minus 13 is 3. And 19 minus 17 is 2. So, since they're all the same, it is linear. That should be glued on the linear side. Okay, so we're checking delta y, delta x on all of them. Here's the next one. Y2, Y1, my second ones. You always subtract the second one first. Can't really see that yellow, but that's all right. Okay, so what's 10 minus 5? 5. 6 minus 2, 4. So change in y is 5. Change in x is 4. Let's try the next one. Change in y is 10 or 20 minus 10. That's 10. Change in x is 14 minus 6. That's 8. They don't look the same yet, but if I simplify, I could divide the top and the bottom both by 2. That's 5 over 4. They are the same, which means this is linear. Okay? Let's try the next one. They might be out of order what's in your notebook, but that's okay. Just write where you need to. Change in y. Change in x. What's 4 minus 1? 3. What's 2 minus 1? 1. So I have 3 over 1. Let's do it on the next one. 16 minus 4. Well, that's 12. 4 minus 2. That's 2. It can be simplified by 2. We have 6 over 1. So far, not linear. Let's double check the last one. It will not be linear if 2 of them don't, but just for practice, let's go ahead and practice the last one. That's 48. 64 minus 16. 8 minus 4 is 4. 48 over 4 is 12 over 1, or just 12. Okay? Not linear. We're not going to get to writing the rule yet, but when we start writing the rule for not linear, we're going to be either using absolute values or exponents. Last one. We already have the difference. We have 10 and 2, so 10 over 2, because that's change in y. Don't forget this, change in x. I'm writing it every time because you need to remember it. 10 over 2, which is 5. 6 over 1 which is 6, not linear. Okay, don't forget homework on graph paper if you have it. If you don't, use notebook paper. You just have to draw the graphs a little differently. Page 67 to 68, numbers 1 through 7. You're graphing them and telling me if they're linear. We'll be absent tomorrow. Miss Knight will be your sub. She'll show you a video right when you come in. It'll have your instructions. You watch the video, you get to work, okay? I know you guys can behave. The best class that she tells me will get a surprise on Friday. Okay, see y'all Wednesday.